Okay, so in a small village, we have two doctors, Dr. Black and Dr. Green, and it says after each year, 3.5%, let me underline this, 3.5% of Dr. Black's patients move to Dr. Green's clinic, and 5% of Dr. Green's patients move to Dr. Black's clinic. All other gains and losses can be ignored. At the start of a particular year, Dr. Black had this many patients, and Dr. Green had this many patients. Write down a transition matrix T indicating annual populations movements between the clinics. Okay, so essentially a transition matrix kind of tells us what's happening from year to year, or from, well, whatever the time is. In this case, it's per year. Anyway, so Dr. Black and Dr. Green, so I'm just going to do a little B and a G just to help explain it, and I'll delete them after. But it tells us this is the current state. The column tells us the current state, and the row tells us the future state. So this is like saying how many, like this element here, the top left, is how many, or what percentage of Dr. Black's patients will still be with Dr. Black. Well, he's going to lose 3.5%. He's losing a few, but that means he's going to keep 96.5%. So that's how many, that's the percentage will stay with Dr. Black. And then obviously he's going to lose 0.035, which is 3.5%. Similarly, Green to Black, well, Green will lose 5% to Black, so he's going to be 0.05. And that means 95% or 0.95 will stay with Dr. Green. So that's my Green to Green. Look, I'm sure you wouldn't lose any marks if you left those letters there, guys, but you're not really supposed to, so I'm just going to get rid of them. Okay, that's it. That's part A. Part B. Find a prediction for the ratio of the number of patients Dr. Black will have compared to Dr. Green will have after 2 years. Now, guys, I'll just tell you something. I just made this video and made a big mistake. I did not read 2 years, and I just did it after 1 year. So be careful. 2 years. If it was 1 year, you just multiply T by the vector 2100, 3500. But because it's after 2 years, you have to do T squared. So it's this matrix squared times the vector 2100, 3500. And that calculates it'll give me how many patients will be with Dr. Black and how many will be with Dr. Green after 2 years. And then it wants it in a ratio, guys, so just be careful. You got to put a ratio there. Okay, so I'm going to do this with my calculator, definitely. Matrix, create a 2x2 matrix, 0.965, 0.05, this is 0.95, and this is 0.035. And then this is multiplied by the matrix, or the vector. It's 2 rows, 1 column. And I want 2100, 3500. Sorry, guys, I nearly did it again. Squared. It's this squared times that. Okay, I get 2294.37, 2294.37, and 3305.36, 3305.36. Therefore, the ratio is, and guys, they accept many simplified versions of this, but let's just go 2294. I'll round it to the nearest person. 2294 to 3305. Okay, that's parts A and B.